Okay, so we're supposed to fill in a Venn diagram for these two events. So I'll make my left circle be A, because we go left to right in our world. This would be B. This is the probability of A and B. And some students might say, okay, where is probability A given B? That's not on the Venn diagram. It's not a place where you can just fill this in directly. You have to use the conditional probability formula. If you have a probability of A given event B, that means you have the probability of event A and B divided by the probability of B. Sometimes we just put probability of B in the bottom. That's what this formula tells us. So we got to do a little bit of extra math here because they said this is 15 over 30 here. Let me write this out the traditional way. This is how we usually see it in our textbook. Okay. And they said that this is equal to 15 over 35. This conditional form is equal to 15 over 35. So we got to do a little bit of extra math to figure out what the intersection is going to be. And let's see. They say there's 50. Okay, so there's 50 students total. 25 take online classes. So 25 are in event A. What this just told me is the probability of A is 25 over 50. And 35 are freshmen, which is event B. Probability of being a freshman is 35 over 50. So we have this in the formula that I just wrote out. So we don't have probability of event A and B, so we can't fill out the intersection in our formula yet. But we know the probability of B now is 35 over 50. And so now we just have some algebra to do in order to get probability of A and B by itself. And so when you have double stacker fractions, this is what I always have my algebra students do. Write it out as a division statement, like I did before, with the symbols. I'm dividing this by 35 over 50. And then you might know what to do, because when you have fractions being divided, you would flip and multiply that fraction, right? So I'm going to multiply that by 50 over 35. And to algebraically get that probability of A and B by itself, I want to multiply both sides by the reciprocal, by 35 over 50. Because that makes this cross cancel, that makes this cross cancel. So that's times 35 over 50. So those 35s cross cancel, so the probability of A and B, that intersection, is going to be 15 over 50, which simplifies to be 3 over 10. Okay, we just did all that work. Finally, we can fill out this part of the Venn diagram. This is 3 over 10. And that's actually, well, based on what we did up here, that's enough information to finish this out. Because over here, it says the number of students, not the probability, so we should write 3 here. No, even bigger. That's the probability of being A and B. So if it's 3/10 of students, we have 50 students, you just need to multiply that, right? Because in other words, that's 15 over 50 students. So 15 students fits here. And now they told us that 25 like online classes. So 25 are in circle A. If 15 are already here, that means there's only 10 left to go over here. That way circle A adds up to 25. Same thing for B. They said B is 35 in total. If 15 are here, 35 minus 50 makes 20 over here. And so we got 10 plus 15 makes 25. 45, we got 5 students that do neither of those two things, neither A nor B. That's what goes on the outside.